All right, thank you. Yeah, so as she said, my name is Brandon Williams. I am a software engineer and manager for our data platform team. Let's see here. So I'm going to talk a little bit about where our sort of the read path for reading data off the chain sort of started, where we're at today, and then delve into a little bit about where we're going and some of the awesome work that the team has done over the last handful of months. And then I'll pass it over to Stefan to talk a little bit more about GraphQL and RPC 2.0. So to sort of start, we'll take a historic look at how data was managed and how we read data from the chain. To sort of start out, today we have JSON RPC. This is sort of served by the full nodes, and so if you want to go ahead and read data from the chain, you either need to spin up your own full node or work with a third-party provider that is spinning up their own full nodes, and they use the normal state sync protocol to be able to get the data. It's super easy for anybody to run. Full nodes easily support it, and so you can just sort of spin up a single binary, and you're good to go. There's no external database. Everything is very self-contained in sort of the one Sui node service. And so this served as a really easy way for when we sort of launched mainnet last year to get to bootstrap the whole process. There are a couple downsides based off of this design, though. One, maybe unforeseen circumstance is some of the standards that have existed, one being the object display standard, sort of require indexing events and from that sort of have happened in the past. And so in order to get accurate responses, you need to have indexed or have the data from these historical events that you might not have if you have started your full node up from a later point in time and not from Genesis. As Sui has sort of grown and gotten a lot larger, we're getting very close to the point where it becomes a little difficult for all of the mainnet historical state to sort of live on a single machine. There's been a lot of work that we've done to sort of improve the status quo here. There's pruning that exists now today, so now you can actually run a full node, and it only has the most recent couple epochs of data. But then you still need to have all of these indexes that were sort of generated from tailing the chain from Genesis. And then we also have this great key value store for if I want to go ahead and query a transaction from a month ago, my full node might have already pruned it, but Mysten Labs has spun up this sort of key value store that these full nodes will sort of transparently go and fall back to read this data from in the event that your full node has pruned it. One of the great things that we have today now are formal snapshots, or this ability to have the validators sign off on basically the state of the world at a particular point in time. And full nodes can't restore from these formal snapshots today because of all this historical index data that they need. And so they need to restore from a snapshot that has the current state of the chain as well as all these historic indices. And the difference in there is pretty stark. These snapshots with indexes are roughly 3+ terabytes now and growing every day. And I think formal snapshots are on the order of still gigabytes, somewhere in the order of 50 to 100 gigabytes, somewhere there. And also the sort of JSON RPC API has sort of evolved to be what we needed it to do at that exact moment in time as we've sort of been growing. And so there's some things that, it's maybe a little overeager about what it can do. And so we're sort of, given these downsides, we want to sort of improve the status quo on here. Let's see here. One of the other challenges is, how do you build an indexer with JSON RPC? Well, today, I guess historically, and I think a lot of third-party indexers out in the wild still use JSON RPC this way. You have an indexer that's in a separate process, and it basically is just pulling a full node. It'll go ahead and it will pull for new checkpoints, and then it will go and for every checkpoint, it'll then make a number of different calls to get all of the transactions. and then all of the objects from each of those transactions. And depending on how large that checkpoint is and how many transactions and how many objects are in there, it could take you roughly 30 to 50 round trips of you going back and forth with this full node to get all of the data that you would need from a single checkpoint. And so this requires quite a bit of effort and time to index a single checkpoint. And so we've had a number of partners be very worried about Sui producing checkpoints every second, and with some potential improvements, maybe even multiple checkpoints a second, this, can make things a little difficult. And then also we still require basically this full node to have full history, or rely on sort of falling back to a key value store to be able to get and service all this data. So sort of the next generation architecture here that we're working on looks a little bit different. We end up with basically grouping all of the data that an indexer would need into a single round trip. So now I can go to a full node, or I can go to a sort of cloud bucket, or we can use this new tool, this new infrastructure using iNotify to get a full checkpoint worth of data in a single round trip. Full nodes can now be pruned. This iNotify system is pretty interesting. Basically, the full node, as it is producing or validating checkpoints, it's going to write out, if configured, write out all of the data that an indexer would need into a file for that one checkpoint, write it out into a directory. The indexer can sit next to the full node, and it can go ahead and listen to and subscribe to the file system events in that directory. And every time the full node writes a new checkpoint there, the indexer can pick it up and process it immediately. And when the indexer is done processing that checkpoint, it can go delete that file. And the full node can then go ahead and recognize that, okay, that checkpoint's been deleted or processed. Now I can go ahead and I can prune up to that checkpoint. And so we've built the system now where your full node no longer needs to have all historical data. It can only have the latest tip of the chain. And then for those instances where you do need to backfill from Genesis, we also have a cloud bucket that has all of these checkpoint files, and the indexer can go and pull these down. It can validate and verify that the data in there is accurate, do all the same checks that a full node would do during state synchronization. We also are going to sort of have a sort of more simpler REST interface to replace the JSON RPC API on the node itself. This will be a little bit more lighter weight. It sort of would be enable validators and full nodes to be able to have this very simplistic API. Correct responses shouldn't need to require historic state. And then the ability to be able to have BCS as well as JSON responses, depending on if I'm a human readable, a human using curl to query a particular piece of information from the full node, or if I am some other process that wants to not have to pay for JSON overhead. And so at a high level, this new architecture kind of looks like this, where you have validators producing checkpoints, full nodes synchronizing those checkpoints and validating them, indexers subscribing to those checkpoints from that full node, processing them, writing them into some Postgres or SQL-like database, and then sort of the new RPC 2.0, which I haven't hasn't been mentioned yet. GraphQL can then go ahead and read that data from the database, and clients, will go ahead and send their requests to this stateless sort of front end. And then now you end up this situation where I've got a traditional database that we all know how to scale, and we all know how to synchronize a little bit easier. And now full nodes are a little bit simpler in what they do. They're no longer sort of this big behemoth of a system. And so I will now pass it over to Stefan, who will talk a little bit more about that GraphQL piece.
All right. Good morning. So let's talk a bit about GraphQL and RPC 2.0. So let me start with why. First of all, it aligns better with the Sui's object model. And that means we have more richer and more expressive queries that we can do with GraphQL. The second point is about previously doing efficient queries for dynamic fields was quite complicated with the JSON RPC. Nowadays, with GraphQL, we have simplified this a lot, and I'll show a brief demo later. Also, feel free to come to me later if you want to. I can pull up the laptop and I can show you what we have with the GraphQL. So nowadays, much simpler to work with the dynamic fields using GraphQL. Third of all, as Brandon mentioned, we are able now, bringing GraphQL, to fully redesign the whole data management pipeline. So that allowed us to also kind of improve some of the issues we have. One of them being, for example, a lot of breaking changes happen in the JSON RPC. Now we'll have long-lived branches, so long-lived releases, which will allow us much better to control for these breaking changes and also allow you to figure out what you want and what kind of version you want to use. And more importantly, the ecosystem is very mature. So we have a lot of libraries, a lot of frameworks that we can use both for backend and frontend, which allowed us to iterate quickly and should allow you also to quickly start using it. A few of the great features that GraphQL has, composable queries, so we can reuse queries, we can kind of compose simpler queries and then have one larger query. This is very, very useful. Then we have extensibility. So the framework that we're using sort of on the source code side allows you to actually add extensions very easily, but you can also take our schema and just build your own GraphQL service. So it's very easy to kind of do whatever you need to do for your RPC. The third one is pagination. So as you know, there's a lot of data, right? So when you have a lot of data, you need to have mechanisms to be able to paginate through it. So GraphQL has pagination via cursors, but the very important part here is that it offers consistency. Let's say you are, requesting a lot of data and you want to see it at checkpoint 100. What we ensure is that all the data you're trying to fetch will be consistent at that time at that point in time, so at checkpoint 100. So you don't have to worry about any data corruption that, new data comes in when you're trying to actually get some data. Finally, there's an online IDE that you can use to explore the documentation, explore the schema, try different queries. So this is, again, allowing a lot of flexibility for the developer to start learning how to use the system. All right. So let me get back to the part with the dynamic fields. You've seen Lou's talk. Lou's around here. So this is a chat between my colleagues, Lou and Emma. So Lou was asking, I need to get the BCS of a dynamic object. How can I do this? And Emma said, well, now you can only do this in one try, one query with GraphQL. You don't need to first ask for the address of the dynamic object and then do another subsequent call to the RPC to get the BCS. You just get it for free. So we have definitely simplified a lot on how to work with dynamic fields, and I will show this in the demo in a minute. Right, so if you're interested in learning more about this, we have the online IDE playground. It's available for all free networks. So you do Sui - the network you want to use, .mystenlabs.com/GraphQL. You'll get this nice interface with colors and pretty formatting and nicely formatted errors and so on. And if you're interested more in the documentation, please follow the link. So if you go to the reference page on our docs website, you can find the GraphQL, which will take you to all the necessary links. All right, so let's try to see the demo. Let's see if this will work, if it will start. Can we please play start? Or maybe I play? OK, yeah, it works. So this is how it looks. I'm on the mainnet. If you click on the left top icon, you see the documentation. So you can click on things and you can read different fields, parameters, etc. So that's the docs. Now what we're going to do is we're going to try to find out if the domain emma.sui is actually registered. Right? So we have the Sui name service. So I'm typing slowly, last evening. All right, so now I want to get the address. So I type the address, and then I format it using that little icon there. And then I press play. and voila, it gives me that there is an address. So actually this domain is owned by this address, right? But now, for example, I want to figure out what are the last 10 transactions that this address has done. So I can go in the same query, I can give it a filter, I say last 10, which gives me the last 10 transactions, and now I paginate through these 10 transactions, and I want to ask for the digest, and I would like to also know if the transaction was successful, and also what were the gas costs for this, yeah? So I say effects and status, and now I search for the gas effects, and I look in the gas summary, and the gas summary, I can check the storage cost, the computation cost, the rebates, and so forth, right? I format it, and now, voila, I get the data that I'm interested in. The digest, the effects, I can see that the transaction was successful, I can see how much it costed. So you can kind of build this query as large or as small as you need, and get the information you want. Now, if you want more, if you're expecting that you'll have a lot of data, you can also use this page info, right? So it has previous page, has next page, and then you can get the cursor where you started, where you ended. So I want to see if we have a next page and the end cursor. So it tells me that there's no next page, and that's obvious because we said we want the last 10. So obviously there's no more data after this, and it gives me a cursor that I can use. All right, for this second little part, let's look at how we can do a dynamic field. So I'll use the system state, the object system state, which is at address 0x5. All right, I'm still typing, so let's wait a second. All right, so we can use the field here called dynamic fields. And now we want to paginate through the nodes, and we have a value of this dynamic field. Now we do a sort of a kind of pattern matching in a sense. We know this is a move value. And now we can get the BCS that Lou was looking for. I don't see her anymore. She left. Oh, she's there. Yes, here it is. You get the BCS bytes. So now you get all the BCS bytes for the system state of the Sui network. Yeah? But for example, you don't want BCS bytes because it's all like weird and cryptic. You want the JSON format. So with the JSON format, as you can see, you can get it, the epoch, protocol version, the system state version, the validators, and so forth. So you can also get this nice JSON representations for these move values. All right, and that was the demo. And I think Brandon and I, we're very happy that you're here. Thank you for listening. And we have a lot of time, 7 minutes, so please ask questions if you feel like it, or you can find us around. Thank you.